When we look up at the night sky, most stars appear calm, distant, and unchanging. They shine steadily, night after night, year after year, giving us the illusion that the universe is stable and predictable. But there is one star that has refused to behave like the others, a star that has confused astronomers, shocked scientists, and captured the imagination of skywatchers across the world. That star is Betelgeuse, a massive red supergiant sitting in the shoulder of the Orion constellation. Betelgeuse is not just bright, it is alive in a way that few stars ever seem to be. It pulses, it swells, it shrinks, it dims dramatically, and then suddenly brightens again. For centuries, humans have watched Betelgeuse without understanding why it behaves so strangely. And now, after decades of observations and years of intense study using the most powerful telescopes humanity has ever built, we finally know what is really happening inside this cosmic giant. Betelgeuse is one of the largest stars visible to the naked eye. If you replaced our Sun with Betelgeuse, it would extend beyond the orbit of Mars, possibly even reaching Jupiter. This alone makes it extraordinary, but size is only part of the story. Betelgeuse is nearing the end of its life, and that fact changes everything. Unlike smaller stars like our Sun, which burn calmly for billions of years, massive stars live fast and die young. Betelgeuse is already in its final chapters, and the strange behavior we see is a direct result of the violent processes happening deep within its core. For a long time, astronomers knew that Betelgeuse was variable, meaning its brightness changes over time. This variability was first noticed hundreds of years ago, long before modern telescopes existed. Ancient observers recorded that Betelgeuse sometimes appeared brighter than usual and sometimes noticeably dimmer. At first, this was dismissed as observational error or atmospheric distortion. But as measurements became more precise, it became clear that Betelgeuse was genuinely changing. It was breathing, expanding, and contracting like a cosmic lung. The real mystery began in late 2019 and early 2020, when Betelgeuse suddenly dimmed by an unprecedented amount. It lost nearly two-thirds of its visible brightness in just a few months. For the first time in modern history, the star became visibly weaker than its neighboring stars in Orion. People around the world started asking the same question: is Betelgeuse about to explode? This sudden dimming event, often called the Great Dimming, sent shockwaves through the scientific community. Betelgeuse is a supernova candidate, meaning it will eventually explode in a massive stellar death visible even in daylight. Could this strange behavior be a warning sign? Was humanity about to witness one of the most spectacular cosmic events ever recorded? At first, scientists were divided. Some believed the dimming was caused by internal processes, while others suspected something external was blocking the star's light. The challenge was that Betelgeuse is not a simple object. It does not have a clean surface like the Sun. Its outer layers are chaotic, turbulent, and constantly moving. Giant convection cells, some larger than Earth's orbit, rise and fall across its surface. These cells transport energy from the core to the surface, and they can dramatically affect the star's brightness. As astronomers turned powerful instruments toward Betelgeuse, a clearer picture began to emerge. Observations from the Hubble Space Telescope, the Very Large Telescope, and other observatories revealed something astonishing. Betelgeuse had expelled a massive cloud of material from its surface. This was not a gentle stellar wind, but a colossal outflow of gas and dust, driven by powerful internal pulsations. When this material moved outward and cooled, it formed dust that temporarily blocked the star's light from reaching Earth. In other words, Betelgeuse dimmed because it partially hid itself. This discovery was groundbreaking. It was the first time astronomers had directly observed a star dimming due to dust formed from material it had just ejected. Betelgeuse had effectively coughed out a piece of itself, creating a cosmic veil that obscured its own glow. This explained the suddenness and severity of the great dimming far better than any internal process alone could. But this was only part of the story. The reason Betelgeuse was able to eject such a massive amount of material lies deep inside the star. Unlike the Sun, which fuses hydrogen into helium in a stable manner, Betelgeuse has already moved beyond that stage. Its core is a layered structure, fusing heavier and heavier elements as it goes. Hydrogen burns in a shell around the core, helium burns deeper inside, and even heavier elements are being formed closer to the center. Each of these fusion processes releases energy at different rates, creating instability throughout the star. These instabilities cause Betelgeuse to pulsate. But these are not gentle pulses. The star expands and contracts by millions of kilometers. When it expands, its surface cools and dims. When it contracts, it heats up and brightens. This alone would make Betelgeuse unusual, but combined with its massive convection cells and violent mass loss, the result is a star that behaves in ways we are only beginning to understand. Another key factor in Betelgeuse's strange behavior is its low surface gravity. Because the star is so large and diffuse, its outer layers are only weakly held in place. This makes it easy for material to escape into space. Even small disturbances can trigger enormous outflows. When convection cells rise to the surface, they can push gas outward with enough force to overcome gravity, launching stellar material into the surrounding space. Over time, this process creates a vast envelope of gas and dust around Betelgeuse. This envelope is not static. It changes shape, density, and composition as the star continues to lose mass. Sometimes this material becomes dense enough to block visible light, causing the star to dim from our perspective. Other times it disperses, allowing Betelgeuse to shine brightly once again. What makes this discovery so important is that it helps us understand not just Betelgeuse, but the life cycles of massive stars in general. These stars play a crucial role in the universe. When they explode as supernovae, they create and disperse heavy elements like carbon, oxygen, iron, and gold. These elements become the building blocks of planets, life, and even human beings. By studying Betelgeuse, we are studying our own cosmic origins. The Great Dimming also taught astronomers a valuable lesson about stellar behavior. For a long time, models of red supergiants assumed relatively smooth mass loss over time. Betelgeuse showed us that mass loss can be sudden, violent, and highly localized. A single event can eject an enormous amount of material, dramatically altering the star's appearance and evolution. As Betelgeuse slowly returned to its normal brightness in 2021 and 2022, it became clear that the star had not exploded. But this did not mean the danger was over. In fact, the strange behavior might indicate that Betelgeuse is entering an even more unstable phase of its life. Each pulse, each outflow, each dimming event brings it one step closer to its final fate. One of the most fascinating aspects of Betelgeuse is how close it is to Earth in astronomical terms. At roughly 600 light-years away, it is practically a neighbor on the cosmic scale. This proximity allows astronomers to study its surface directly, something that is impossible for most stars. Using advanced interferometry techniques, scientists can create detailed images of Betelgeuse's surface, revealing bright hotspots, dark regions, and asymmetrical structures that change over time. These images show that Betelgeuse does not have a smooth, uniform surface. Instead, it looks like a boiling pot of plasma, with massive bubbles rising and bursting. These bubbles are convection cells, and they are far larger and more powerful than anything seen on the Sun. Their motion contributes to the star's irregular brightness changes and helps drive mass loss. The more we study Betelgeuse, the more it challenges our assumptions about how stars behave. It is a reminder that the universe is not always neat and predictable. Even the laws of physics, when applied on a massive scale, can produce chaotic and surprising results. Despite all we have learned, Betelgeuse still holds many secrets. Scientists are continuing to monitor it closely, using both ground-based and space-based telescopes. They are tracking changes in its brightness, temperature, size, and chemical composition, hoping to catch the next major event as it happens. One of the biggest questions remains unanswered: when will Betelgeuse explode? The honest answer is that no one knows. It could happen tomorrow, or it could happen 100,000 years from now. In astronomical terms, Betelgeuse is living on borrowed. But in human terms, its explosion is not guaranteed to occur within our lifetimes. What we do know is that when it does explode, it will be one of the most spectacular sights humanity has ever witnessed. The supernova of Betelgeuse will briefly outshine the moon. It will be visible during the day, casting shadows on the ground at night. For weeks or even months, it will dominate the sky, a brilliant reminder of the power and beauty of the universe. And then slowly it will fade, leaving behind a neutron star or possibly a black hole. Until that day comes, Betelgeuse will continue to behave strangely. It will pulse, dim, brighten, and shed its outer layers into space. Each strange behavior is a clue, a message from a star in its final act. And thanks to modern science, we are finally learning how to read those messages. Betelgeuse is not broken. It is not malfunctioning. It is simply doing what massive stars do when they reach the end of their lives. Its strange behavior is not a mystery anymore, but a story of instability, transformation, and cosmic creation. By understanding Betelgeuse, we are not just learning about a single star. We are learning about the forces that shape galaxies, seed planets, and make life possible. And the next time you look up at Orion and see that reddish star glowing in the sky, remember this: you are not just looking at a point of light. You are witnessing a living, changing, dying star, one that has finally revealed the reason behind its strange and beautiful behavior.